Welcome to the Math Help Room, your YouTube resource for all things math. Today's lecture is titled What is a Function? And this is lecture 1 in our Pre-Calculus series. In this lecture, we shall define functions and learn some of the basic terminology that goes along with functions. We shall look at 3 different ways of representing them, namely through diagrams, one of the easiest approaches of representing functions, through set notation and ordered pairs, and lastly, through equations, which is by far the most common way of representing functions. We start then by defining rigorously what a function is. A function f from a set capital X to a set capital Y is a correspondence or a rule that assigns to each element lowercase x from the set X a unique element lowercase y from the set Y. In this notation, lowercase f is the name of the function, x is called the domain of the function f, and y is called the codomain of the function f. If an element lowercase x from the set X is associated to an element lowercase y from the set Y under the function f, we represent this by writing f in parentheses x is equal to y. This notation is ubiquitous, and you will see it in many upcoming future lectures in this series. We call x the independent or input variable for this function and y the dependent or the output variable for the function f. If you gather the set of all output values of the function f, that is called the range of the function f, and it's denoted by range and in parentheses f. And observe that the range of f is a subset of its codomain, sometimes equal to its codomain, but sometimes a proper subset of the codomain. In our first example, we look at how to represent a function using diagrams. Recall that a function consists of 2 sets, x and y, the domain and the codomain of the function, as well as a rule of correspondence between elements of these 2 sets. So in this example, we represent each of the sets by an oval, the first one being x, and then we explicitly list the elements that we want this set to contain. In this example, it happens to be the names of 5 famous scientists. So similarly, the codomain, our set y, is represented by an oval, and here too we list explicitly the names of the elements in this set. The name of the function in this example is country of birth, which gives you an idea of how elements from the set x should correspond to elements from the set y. That correspondence is indicated by simply drawing arrows. So for example, Albert Einstein was born in Germany, and we indicate that in our function by drawing an arrow from Einstein in the set x to Germany in the set y. Nikola Tesla was born in Croatia. We represent that by a second arrow. Marie Curie was born in Poland, and both Richard Feynman and Carl Sagan were born in the United States. In fact, both were born in New York City. Next, we look at how functions can be represented as ordered pairs and how set notation is used in this way of representing functions. For simplicity, we shall look at the same function as we used in our first example. So in this setup, we represent the set x by listing its elements in a comma-separated list enclosed by curly parentheses. So we write x equal, open curly parentheses, Albert Einstein, comma Nikola Tesla, comma Marie Curie, comma Richard Feynman, comma Carl Sagan, close the curly parentheses. This represents the domain of our function. Similarly, the codomain is also listed in set notation, so we enclose its elements in curly parentheses and write y is equal to Croatia, comma Germany, comma USA, comma Poland, comma France, all enclosed in curly parentheses. Using this set notation, we have represented the domain and the codomain of our function. Next, recall that the function name is the country of origin, which gives us a clue as to how the correspondence between these 2 sets should work. And how do we represent this correspondence? We do so by listing ordered pairs. So for instance, to indicate that Albert Einstein from the set X should correspond to Germany from the set Y, we list an ordered pair, with the first entry being Einstein, the second being Germany. We list another ordered pair, Nikola Tesla, comma Croatia, to indicate that Nikola Tesla was born in Croatia, and so on. So we list 3 more ordered pairs: Marie Curie, Poland, Richard Feynman, USA, and Carl Sagan, USA. This way of representing function contains the exact same information as our first example that used diagrams, but is not nearly as visual. In our third example, we examine how functions arise from equations. By way of example, consider the equation y equals 3x minus 1. So this is an equation linking 2 variables x and y through this very simple relation. This equation determines a function f whose domain x and codomain y happen to both be equal to the set of real numbers, and the correspondence rule f for this function is given by f of x is 3x minus 1, telling us that for an input variable x, the corresponding output variable y for this function is obtained by taking its input variable, multiplying it by 3, and then subtracting 1 from that. Sample input-output pairs for this function are given by f of minus 1 is minus 4, f of 0 is minus 1, f of 2 is 5, and f of the square root of 2 is 3 square roots of 2 minus 1. Functions represented through equations are by far the most common. It is worthwhile pointing out that in general, for a given equation, the domain of the resulting function may be a proper subset of the real numbers rather than equal to the entire set of real numbers, as was the case in the example that we considered here. This is an interesting question, one that we shall return to in a future lecture.